Each month, the Security Ledger podcast informs and entertains an audience of thousands of information technology and cybersecurity professionals. If that sounds like an audience your company is trying to reach, consider becoming a Security Ledger podcast sponsor. We offer per-episode sponsorships of our regular podcast, which features news, analysis, and discussion of the most important security topics of the day, or you can commission a custom podcast that highlights your executives, researchers, and subject matter experts. To learn more, point your browser to securityledger.com/sponsor. Hello and welcome to the Security Ledger podcast. I'm Paul Roberts, Editor-in-Chief at the Security Ledger. In this episode of the podcast, number 250, the growth of the Internet of Things is one of the most significant developments in information technology over the last decade. During that time, our homes, workplaces, and public spaces have become populated with a wide range of smart, software-driven and internet-connected devices ranging from printers and cameras to home appliances and heavy machinery. Cyber threats and attacks have followed, however. A recent report from Cisco found that the growth of the Internet of Things and connected devices were the biggest contributing factors to organizations' expanding attack surface. Part of the reason is that device makers and the development organizations that serve them have struggled to learn the lessons of the last 30 years. Embedded software running smart devices in everything from homes and businesses to critical infrastructure repeat many of the same mistakes that have plagued earlier generations of software and services, from buffer overflows to SQL injection to weak authentication schemes. Our guest on this week's podcast thinks she has a solution to that problem. Rather than wagging a finger at IoT device makers, why not provide them with the tools, technology, and support to make developing secure embedded devices easier? Window Snyder is the CEO and founder of Thistle Technologies. In February, Thistle announced the launch of Thistle Security Platform, a set of tools and services that bring software updates and other security functionality to the world of embedded devices. Window's a security industry veteran and former chief security officer at Square, Fastly, and Mozilla. She spent 5 years at Apple, responsible for security and privacy strategy and features for OS X and iOS. Window's other roles include chief software security officer at Intel, security something or other at Mozilla, and founder of Monosano, a security services and product company based in New York City that was acquired by NCC Group. To start off our conversation, I asked Window to tell us a little bit about her latest project, Thistle, and what inspired her to dive into the IoT security problem. Okay, welcome back to the Security Ledger podcast, and I'm really thrilled to have with us in the studio Window Snyder, who's the founder and CEO at Thistle Technologies. Window, for the folks who aren't familiar with you and with Thistle, just tell us a little bit about yourself and about your company.
Sure. So I started Thistle Technologies because I saw a problem in the industry that it's been bothering me actually for a long time. For having worked on a number of different operating systems, a number of different platforms, a lot of the security work that went into these general purpose operating systems hasn't made its way to devices. And in my work at Apple, I got to see, what it takes to make update, for example, a reliable mechanism for the phone, which is really different than trying to do update reliably for a web browser, for what it's worth. For a web browser, if update fails, as an example, the user can mostly get themselves back into a good state, right? They can either try it again, or they can reboot the machine, or one way or another, the user can mostly figure it out. But for a hardware device, right, you've got a much lower tolerance for failures in these spaces. So reliability ends up being a critical piece of it, because for a device, if an update fails, right, that's a phone that's got to come back to the mobile store, or it's a car that's got to come back to the dealership, or it's a technician that's got to visit the television in your house, or it's a factory manufacturing line that's shut down until a technician can get there, or if it's a satellite, it's just gone forever, right? So the tolerance for failure in these spaces is really low. And then what I was seeing was that for the most part, even if they had update mechanisms, they weren't being updated because the analysis between whether to deliver an update versus the possibility of failure was this calculus that these device manufacturers had to consider every single time. So reliability was a really critical piece of it. But I was also seeing, especially my role at Intel, where I was the chief software security officer, I got to see like this industry scale perspective of what device security looked like everywhere. And honestly, I was seeing things like a lack of separation of privilege, a lack of separation between code and data. And for what it's worth, that means, without memory corruption mitigation, you start to see things like exploitation looks like it did in the 90s, mid 90s on general purpose operating systems before we had memory corruption mitigation on these devices. So it really felt like a lot of the problems that we had seen really early on just hadn't made the solutions hadn't made their way onto devices. And it's not surprising because these are, much more constrained in resources, whether it's space or compute power or battery. Like the amount of energy used to power up a radio is considered for these devices. And then of course they're attached to like critical systems that, it's national infrastructure, it's everything, right? So the combination of high security requirements and then low tolerance for anything that's going to mess with reliability combines to keep the systems as simple as possible. But they're not resilient enough against the security threats that we see today. And then in addition to that, they're deployed on a completely different timeline. Like, how long is that MRI in place in the county hospital? How long is a car running around on our roads? Like the lifespan of these devices is so long. So not only they're not up to the security threats that they are dealing with today on the day that they're deployed, but additionally, they have a much longer lifespan. So they need to be resilient against security threats, 10, 20 plus years out. And so it seemed like, this massive space in the industry where there was an opportunity to make it easier for folks to get to a modern security architecture.
Was there an aha moment for you with IoT and security? You mentioned you were at Intel before that, you were at Apple, you were at Mozilla, you were at Microsoft, going all the way back to sort of at stake. So you've worked for both traditional software publishers, some of the largest in the world, as well as device makers and everything in between. You worked at Square. So when did this sort of idea of, wow, IoT is really where the problem is that I want to dive in on?
Sure. So in my role as a CISO, both at Fastly and then more recently at Square, I would consider these devices that were being deployed in our environment, and they were unmanageable. Just frankly, devices were unmanageable. And so if you even get a response back from the vendor about the security of the device, not only was it unsatisfying, like, we use military grade encryption.
Yeah,
fantastic. Thank you. That tells me nothing. Right? Or if you get it back, it's definitely not up to the same security requirements as the rest of the environment. But then it's very often sitting on the same networks. Like, for example, your printer is, in order to be able to use it, it's got to be in the same networks as your workstations, right? And if you have a devices network to try and isolate them, then eventually you have all your devices on this device network. And so the device network still has access to all these incredibly important and critical resources. So there's a degree of complete, just lack of manageability. And then additionally, just seeing how, or knowing how vulnerable a lot of these devices are. And then, of course, for running teams that build the security features that go into these devices with high security requirements, seeing how much it costs to build that organization to build security resilience into these devices to a degree that's appropriate for the threats that they're up against. And I was like, we don't have 20 plus years for the rest of the device industry to catch up. And we definitely know that they can't spend what those big companies that have done well with device security or platform security. That's not scalable. It's just not available to everyone. And then you've got all these really cool startups, really cool smart engineering teams that don't necessarily have any security engineering folks on board, but they're building devices that are, taking over logistics. They are space startups that are building new devices with off-the-shelf components. There are a lot of teams that just don't even have the security engineering organization that they needed in order to build this kind of security resilience. And then for the teams, the large companies that do have sophisticated security engineering teams, I know that there's a laundry list, a mile long, of the set of things that they need to get to. So the aha moment for me was seeing just how big the problem was, how widespread it was, and realizing that like the things that I've built into other platforms are things that would benefit the device industry as a whole if we could find a way to generalize some of these problems. So that's what we're building. We're building tools, libraries, and backend services that allow these device manufacturers to put together the security components that are appropriate for their project and leverage it within their existing technology investments. So they don't have to move to a whole other operating system and do a forklift upgrade to get modern security work on their project. And so that's what we're building, and it's really gotten such a wonderful response. We have this one company that we've talked to that like ships hardware that has this low level security capabilities. It's got a security element that they want to be able to leverage. They just didn't have anyone on board that was equipped to build to this hardware capability. So they've already paid for it, and they're not able to leverage it in their product, or at least not right now. It's something they wanted to get to. So anyways, being able to make it easy to incorporate this kind of security work, these discrete security sensitive components into your project, allows these device makers to quickly get.
And is the Thistle platform about the development side of things, the software development side of things? Is it about build and deployment, supporting devices post-deployment? Like, where do you guys fit in the whole dev pipeline?
Yeah, so it's definitely developer tools. It allows developers to incorporate these tools, some of them as libraries, into their build. And then on the back end, there are services to allow folks to manage the services. So if you take update as an example, there's a component that's built into the device. It's on the actual device itself. There are developer tools that make it easy. So things like partitioning the drives and deploying it onto the device. There are developer tools that allow you to incorporate, let's say, a memory allocator with modern memory corruption mitigation that makes it more difficult to exploit memory corruption issues that might be present in low-level code on the device. And then a TLS stack that is implemented in a memory-safe language, which means that you can get to a place where you can say, all of my network-facing attack surface is implemented in a memory-safe language, which means something. That's a tangible security improvement that's measurable, right? So being able to say that you've mitigated the network-facing attack surface in that way is meaningful, especially to a smart security buyer. So those are developer tools. And then we've got the backend components, the services that allow you to deploy your updates and manage your updates, which can also be white labeled for your customers, so that your customers can use that to manage the devices in their environment, independently of however you might be, managing devices from the cloud or on-prem. If there's definitely some providers that are some folks who are deploying devices that have security requirements that don't allow them to connect to the internet, right? So for those folks who want to make sure that they're able to do updates and leverage these security features.
Over-the-air updates is big security risk for IoT devices, also an important security feature of them, being able to push out software updates, firmware updates, keep them patched, and also push out new features if that's what you're doing. Thistle just released a OTA product to help secure updates. Can you just talk a little bit about how that works?
Sure. So there's a developer tool that you, as a developer, use to build the client into your device. It partitions the drive so you have a failover. It helps you do your key management so that your updates can be recognized as coming from you, the developer, and not from who knows where, to validate updates. It allows you to deploy your updates and manage them. So you can set device groups. You can do A/B testing. You can do a slow rollout. You can also use it as a developer for just continuous integration, right? You've got like 6 or 7 devices on your workbench, and your current plan is to go around with a cable to deploy your new build every time you make a change. That's a pain, of course. So being able to create a device group with just your devices and deploy the build to the device, or even one build to this device, another build to that device, and so on, allows you to very quickly get to testing on your actual device instead of testing in a simulator, which we all know they're not as similar as we hope. For this testing on the actual device, there's nothing that can replace that. So it's very useful for developers.
We often talk about the need for IoT device makers, really anybody, to make security part of the design process, right? To have security as a consideration from the early stages of conceptualizing a product or service versus bolting it on. Do you work with companies on that, right? To even know what questions to ask or what problems to solve and help guide them in that part of the product design process?
Yeah, we hope that our developer tools allow folks to identify security features that they maybe hadn't considered or didn't know that they could do easily. And so discoverability is a significant part of this. We want to be a partner to our developers, that like we're a great place to find security functionality that maybe hadn't considered, that maybe it's adding something that their customers appreciate, or maybe their customers expect that's not in place. That if you've got a small team that maybe doesn't know where to get started, this is a great set of things to take care of. Update memory allocator and your network facing attack surface to implement it in a memory safe language as a starting point. That's great in terms of overall reducing risk to your device. But then the next level, and we have this coming out in short order here, is secure boot and leveraging key management, leveraging a security element if you've got that present on the device. And that's kind of like that's more sophisticated in terms of the security work that would otherwise have to be done by these developers. So they might not even be considering it for their device because they haven't been able to even address like the basics. And then being able to put together a compelling security story for their customers when they get that question, or they get that 200 questionnaire about what they're doing in terms of security. They've actually got some good answers now about like their key management program for signing updates and how updates are signed, and what their network facing attack surface looks like and what they're doing to mitigate that. And so, yeah, our goal is to really be a partner to these developers and help them both address the security needs that they know about and help them identify new ways for them to make their security resilience much more robust.
When I think like common IoT hacks or incidents, often the ones that make headlines are the webcam, nanny cam, the smart doorbell, or the home router, broadband router. And the problems are often weak authentication, default admin password, it's the exposed telnet port, or the out-of-date firmware with the RCE vulnerability in it that just device never got updated. Is that a lot of what you see out there in the sort of IoT threat landscape? Or what do you consider the biggest and most common risks that you all come across just in this IoT space, and that Thistle is looking to address, nip in the bud?
Yeah, there are, honestly, in the entire like history of application security or product security, I would say present in devices is the entire spectrum, like from the 90s on up. Like like if it ever happened on any kind of platform, it's absolutely present on devices today. I would say the worst is security feature just not implemented. No one thought about it. Nobody put it in place. So never mind a vulnerability, more just like it's just not present. That's like the first and most significant chunk here. And then the next is insufficient to the threat. That like you've got more of like a 90s or early aughts style security solution for 2023 plus security problems and adversaries. So there's a lot of that. And then you've got, okay, we made an attempt. Like we built an update mechanism. We signed our updates, or we attempted to, and we failed in validation. And we see that one quite a lot. Or we implemented everything and it was reasonable. And then like Hyundai had this problem where they implemented code signing and validation, but then they used the key for signing that was part of the example code. on the NIST website, right? Like that sort of thing, where it's just like clear that the developers didn't understand the security considerations around the implementation. So even if they get the implementation right, there's there's more. There's more to it than just the implementation. There's also building to resilience, right? Like building a security feature so that it's functional. Okay, the thing is encrypted is really different than answering the question about like, okay, how is someone going to try and circumvent this, and what do I do to mitigate the ways
Kind of
that people will try and
like the
attack this
hacker
system that's
stuff.
designed to secure something else? Exactly. And like, even just basic questions like, okay, where's the key stored? How's the key generated? Where's my source of randomness coming from? Is it sufficiently random? And things like that. And that's just like really basic security questions. So I'd say it's attempted a security feature or a feature that has security considerations, but um, implemented it from a functional perspective and not necessarily from a resilience perspective. There's a lot of that. And then there's memory corruption, because a lot of these devices are implemented in very low level languages and with memory allocators and memory management that doesn't have, let's say, all the benefit of the work that we've done in this space to mitigate this. Although moving to memory safe languages will really mitigate that. And that's getting a little bit of traction. And I'm really excited to see more folks implementing device code in memory safe languages. I wouldn't say it's widespread enough to mitigate that as a threat. So there's that. And then of course there is the way that they're connected and the services that they use in order to move data around. That's absolutely a vector.
One of the things we're seeing in the broader threat and attack space is a big shift in focus to software supply chains, attackers setting up typo squatting modules on NPM or GitHub and just hoping to trick developers to using some malicious component, or trolling around looking for leak secrets or credentials that they can leverage in some kind of an attack. Is that as much of an issue in the IoT space, in the device space, as it is in the more general kind of AppSec world, or not?
I would say that if it's a security problem that developers have, then it's going to be present on devices. I think devices get a lot less inspection, but it doesn't mean that they're completely opaque. They're just, maybe they're opaque to the IT team that's deploying it. They're not opaque to attackers.
Biden administration has made some really interesting announcements and moved the needle a little bit on cybersecurity in general and supply chain security. The executive order, and they've had guidance that's come out subsequently. There have been rumblings that there might be some IoT specific guidance or standards that the administration might float, although we haven't seen anything. We've heard comments from people like Jen Easterly, certainly calling out device makers to raise the bar on security for their devices. I'm really interested. Obviously, you're CEO of a startup that's in this space. Have you seen any increased interest or attention in like Thistle's technology as a result of the noises coming out of DC? Do you have any thoughts on whether we might see some IoT security mandates really coming from the administration?
I don't know, but the pressure is building, whether it's coming from regulatory or if it's coming from customers. As security researchers demonstrate the problems, folks get more uncomfortable that like, oh, is this present on my device? Or this is a device that I deploy. What does that mean for my device? And once you have any device in your environment that has a problem like this, now you start looking at all your other devices and you see how little information you have about them and how they're built. And it's hard to evaluate what degree of confidence you should have in these devices. So it can come from regulatory pressure, it can come from customers, it can come from security researchers. And I am thrilled that there are more and more security researchers both sharing their work and calling attention to these kinds of problems, because we're not in a great state. I'd say it's a huge area of vulnerability that isn't getting the same degree of investigation that we've fortunately been able to have for web applications and for services and so on. So I think it's going to be a little painful for a bit, and then hopefully we will see things start to improve. But it's hard to justify making an investment for a lot of these companies until they recognize that there's a problem. So I would say consumer devices, yeah, those folks probably aren't feeling the same kind of pressure that the kinds of folks that we're talking to, the folks that we're talking to already know that they've got security requirements. Those folks know that their customers have security expectations. And so for those folks, they know they're protecting medical data, financial transactions. Those folks know that they've got security work that they have to do. So that's overwhelmingly who we're talking to. But I think it's just a matter of time before consumer devices wake up and realize that they've got all the same security requirements on these devices, and that it's not something that they can
Two more questions.
Continue to kick down the road.
Thistle sounds like an amazing platform. If you're in the planning stages of launching a new IoT device product, definitely want to work with Thistle, right? They've got all this great security functionality. But man, what about all the companies that have already built their connected product, have it out there, and are maintaining, updating it? Do you have something to offer to them, or is it sort of the horse has left the barn? So that's the first question.
You can absolutely continue to improve the security of devices that are deployed. So, updates is just one of the features. You can over time add security functionality to these devices, or security resilience to these devices. I guess depending on how willing you are to ship an update based on your existing update mechanism. There are even some devices out there that have like completely changed operating systems in deployment once they're in the field. So it really just depends on how important it is for that device. It depends on their existing confidence in their update mechanism. But yeah, if they're not able to ship updates, then there's to improve the security of that existing device in the field. They might be able to do some work on the back end, for example, but that's a different story. So I'd say overwhelmingly there are devices out there that have update mechanisms that will allow them to continue to improve their security.
One of the questions I think, obviously I do a lot of work with like right to repair as well, and repairability and serviceability of connected devices. And one of the things I think about a lot is the sort of what I've written about is the Internet of Zombies, right? Which is as the IoT ages, right, companies are increasingly walking away from products that they may have launched and supported, either because the products are end of life or because the company has been acquired or gone out of business and isn't interested in maintaining this product or can't support maintain this product anymore. That creates kind of a public health issue on the IoT, right? Which is abandoned, unsupported, unsupportable devices. I'm really interested in your thoughts on what is there either a technology or a policy or a technology plus policy fix to that problem, given that it's only going to be a problem that gets bigger over time?
I do think it's a problem that's going to get bigger over time. I do think it's incredibly difficult to ship updates for someone else's product without having an idea of how it works. But there are also a number of, communities out there, device hackers, who want to take something and make it useful again. So you can deploy a new operating system on your existing router if your router manufacturer has stopped shipping updates for it. And this is actually, we actually did a blog post on enabling update into OpenWRT. And the reasons we want to do this is because, first of all, we love OpenWRT. And then second of all, that if one of the reasons it's difficult to use is that they don't have an update mechanism that allows you to do over the air. And it makes sense because they support 400 devices, and that's hard. They don't want, to ship an update that's going to like brick your devices and require you to go out there by hand. But this is a platform that allows you to bring some of those old devices back to life. And so I think we'll see some of those kinds of things, like, a community of sewing machine hackers who, take the existing firmware and make it more useful than it has been in the past. And so I think some of those devices will get a longer life because of this. And some devices are going to be made obsolete long before the mechanical components of the device are going to fail. And I think that's a crime that is just awful, because it is so wasteful to have, let's say, a car that's perfectly functional, but like is so incredibly vulnerable that you feel safe driving it, because human safety that we're talking about, right? So they stop shipping updates. Now we're talking about human safety as the potential outcome of somebody compromising that device. So yeah, no, I don't know how things are going to go here, but I do think that there's a really serious conversation to be had here about is it ethical to make these devices completely unsupportable?
Or I always think about the kitchen appliance, right? So the person in Best Buy is, yeah, I'm buying this refrigerator for, it's going to last me 15, 20 years. Small print, we're only going to support updates for this thing for 5 years. And it's like the consumer at some level needs to understand that. You're going to get 5 years of software updates with this. After this, you're on your own. Can you shut off the connected features? And if not, and in doing so, are you going to somehow cripple the device or features on the device that you're paying money for now? And all these kind of conversations are not happening. And I think that they need to be.
I think the manufacturer is actually even making a statement about how long they're going to support updates. Very often
Yeah.
it's like, buy it, and you have no idea if they're going to support you for 10 minutes or 10 years.
Yeah.
And these devices have a really long lifespan. That refrigerator is going to be in place for a very long time.
Indeed. Window, is there anything that I didn't ask you that you wanted to say? That's a negative construction of that sentence. I'm trying to think of the opposite of.
No, I really enjoyed being here, Paul. Thank you so much for having me.
We really enjoyed having you, and I'd love to have you back and talk some more. I'm really excited to see where you go with Thistle.
Thank you. I would love that.
All right.